Welcome to this PV Tech Tech Talk product series webinar with DSM's commercial manager, Jorn Brembach, and myself, Mark Osborne, senior news editor at PV Tech. The title of this webinar is Spring Cleaning Your Solar Park. Why not boost its energy output too with DSM's Retrofit Anti-Reflective coating? This product series webinar is actually designed to provide some of the latest developments in retrofit anti-reflective coating analysis and strategies that did not actually appear in the previous webinar we hosted with DSM, which also included Jinko Solar and Wise Energy on March the 12th. Those can be watched again online on PV Tech and YouTube. So I will be running through a number of key areas with Jorn and finish with some audience questions and answers today. We also welcome the audience at any time during the product webinar to ask questions, and we'll try and cover as many of those as possible at the end. Jorn, welcome. And let's start with just a short overview so the audience can grasp the fundamentals. Okay, Jorn?
Yeah, Mark, thank you so much for your kind introduction. Dear participants, also on behalf of DSM Advanced Solar, warm welcome to our Tech Talk product series webinar. So let me put the overview to the screen. Next minutes of presentation, we're going to inform on what is DSM at a glance. You will get an insight on the reason why DSM has commercialized a retrofit anti-reflective coating for older PV panels. This is a Tech Talk webinar, so we will have it a bit about the physics of the technology. Next, we will look at it from different stakeholder perspectives with special attention to the cleaning and coating of the modules. And I will summarize with an outlook to the future. All right, from century-old roots as the Dutch state mines, DSM has evolved into a purpose-led science company with 9 billion euros turnover, numbering 22,000 people worldwide and specializing in solutions for nutrition, health, and sustainable living. And our purpose is to create brighter lives for all. So we have this special heritage in primary energy sources. And within the DSM Innovation Center, a dedicated team named DSM Advanced Solar is now developing and commercializing innovative materials for the solar industry. Our materials portfolio can be seen here. It all started in 2011. And now we are the market-leading company in anti-reflective coatings for solar front glass. The installed base is already more than 76 gigawatt peak. That equals to 250 million solar panels installed in the field. In recent years, we have introduced an anti-soiling coating and came up with backsheet products as well. And last year, we fully commercialized our anti-reflective coating for the aftermarket application, which is focus of today's Tech Talk.
Okay, thank you, Jorn. Can I just ask here, could you tell us why the retrofit anti-reflective coatings provide opportunities for PV power plant owners and operators? This is obviously a key aspect here.
Yes, I think I can. The basic question is, why should somebody make use of a retrofit anti-reflective coating in older solar parks? And I like to provide you with the big picture. First of all, old means solar parks that were installed before 2011 to 2012. In this period, the market introduction of anti-reflective coating technologies happened. And these old solar parks, now 10 years old, will receive feed-in tariffs for another 10 years, but have already degraded, most time in single-digit percentage range. So our coating will provide a reverse effect and increase the power output by 3%. All of you can do a little conservative math with 3% extra power output and come to the conclusion European solar industry is leaving about 120 million euro per year on the table. This equals to almost 1 billion euro until end of feed-in tariffs. These numbers are based on about 15 gigawatt peak of old panels installed in main markets of Europe.
Okay, I understand that, but From a technical solution perspective, Jorn, can you just provide a brief explanation behind the science behind this?
Yes. So some words to the physics behind anti-reflection technology using this simplified illustration here. Starting with the definition of the term reflection. Reflection in common is the change in the direction of a wavefront at an interface between two media, so that the wavefront returns into the medium from which it is originated. So when sunlight meets a solar panel glass surface, some of the light is reflected. The interface between the two media is described by the difference of refractive indexes as well. And the refractive index of air is 1 compared to about 1.5 of solar cover glass. And anti-reflective coating works with a refractive index in between these two values. It provides an incoming photon with a more gradual transition from air to glass. In theory, the maximum gain in transmittance of a single layer nanoporous anti-reflective coating with perpendicular light is slightly above 3%. On top of this, in outdoor conditions, there's an angular effect that can add another 1%. So the total gain in outdoor conditions can add up to around 4%. The coating structure of DSM Retrofit Anti-Reflective coating is similar to our proven core shell technology for brand new solar cover glass, which is applied in glass factories. And our Retrofit Anti-Reflective coating is a nanoporous coating 1,000 times thinner than a human hair. Once applied, it cures in less seconds. And of course, with a refractive index in between that of air and glass. After DSM's retrofit anti-reflective coating is applied and cured, it is totally UV stable silica, the same substance as the glass beneath it. What makes it different is during the outdoor curing process, it creates a unique closed pore structure. And that's different to other coatings where the surface roughness is much higher and a more open pore structure exists. We have a granted patent on this technology, and definitely we will continue to protect our developments. Our coating has been optimized to maximize durability. It has gone through comprehensive, also independent testing, both in-house and in the field. Of course, we have executed all the usual IEC 61215 tests, like damp heat and humidity freeze, as well as extended durability tests. Even post-application cleaning testing studies were carried out. Our coating passes all these tests with minor changes in optical and other relevant properties. And this gives us really the confidence that the coating will also have an excellent long-term outdoor durability.
Okay, Jorn, but how is this product actually assessed?
DSM has extensive experience in outdoor validation and data analysis. For our clients' parks, we have developed a stepwise process to ensure that data is gathered and analyzed to help ensure objectivity and accuracy. In the picture from a project 2.5 years ago, you see the boost in output coming from a baseline, here colored in red, right after the coating application. We are currently validating the performance of the retrofit anti-reflective coating on string level in all of our coded fields, where we compare the performance of coded modules and its historical string monitoring data with the strings from uncoded panels, which we call reference.
Okay, understood. But how is this actually applied in the field? As I think everyone understands that this is obviously a key aspect for people to really understand what benefits this coating has.
Yeah. First of all, we do a pre-analysis of historical monitoring data and match it with the as-built documentation of the solar park. And we carry out an initial site visit and prepare a project management script. And in the field, we provide a turnkey service. We wash the panels, and therewith we may save the client its planned spring cleaning activity. And then right after we spray our Sol-Gel technology directly on the panel. We need normal weather condition. If it's raining, we have to stop. Our spray coating applicator is tractor driven, which ensures a steady and outstanding fast operation. But please accept that we do not show a live demo of our coating application process. It's quite fancy and designed with passion from our application development team. And as I told, we protect our IP and we are ahead of competition here. We want to keep this momentum in terms of pure application speed, multifunctionality, and uniformity of the coding. What I can tell you is that we are able to provide a massive economy of scale by coding module table designs of up to 3 modules portrait or 5 modules landscape. That's in one run, and we will further improve this season. Our service is embedded in a very good service level, and in a well-maintained park, the local O&M has no extra work and almost zero plant downtime. Of course, operation and maintenance companies have to take care for security and that all the legislation is met if they allow third parties like us to enter their site. DSM takes this very serious and has made its homework. Our retrofit anti-reflective coating is safe to handle, to store, and to apply based on an extensive independent environmental risk assessment we have carried out. The machinery itself bears a CE label. It is safely operated by our qualified and valued ecosystem partners, Stern Energy in Italy and Green Tech in Germany. For the local operational maintenance company, there is most time another good takeaway from our detailed field data analysis. They get insights in their parks, in their malfunctions or even disorders. And then they use this information for their normal preventive maintenance.
So Jorn, how do you actually approach the bankability factors here, around the product and especially for PV plant owners?
Yeah, Mark, in solar industry, almost all B2B decisions are made on bankability considerations. And you still remember the 1 billion euros opportunity from the beginning of my presentation? It is not worth anything without a reliable, trusted partner like DSM, who is simply no startup and is there for the long term. DSM, with a balance sheet of almost 10 billion and a proven track record in solar materials, provides the financial strength and all the bankability items for secured project payback periods, which are mainly get contracted below 3 years. And some of the bankability items we provide on product and company level are listed on this slide. Our product is in full compliance to European regulation, so it's registered under REACH. For the parks where the module warranty is still valid, we use our relationships with many module makers we have from our existing business. Of course, our retrofit product is relatively new to the survived module makers, and there are different ways to deal with their module warranty. One has published an application note, others have given project-wise or general notification that the warranty is not touched by our product. In any case, we support our clients, but module makers as well, to assess our technology and demonstrate that risk to the module due to coding is essential. All our activities in the solar parks are insured against direct damages. And our advanced service level agreement includes a financial compensation, which confirms that the cost of the coding and application will be earned back in a given time. And with this, there is zero risk that the customer's investment will not be paid back.
Okay, understood. But obviously, a lot of companies want to see examples of external bankability related reports, analysis. What do you have on those?
Yeah, as told earlier, we have strict environmental performance testing and durability examination in place. But herewith, I also like to provide you with our independent electrical power performance testing that was carried out by TÜV Rheinland in Cologne. A group of 25 modules was stabilized and flash tested on this very accurate TÜV Rheinland equipment before and after retrofit coding application. And you clearly see the nominal power uplift from an uncoded control group on the left to the one that was retrofit coded here on the right. The average nominal power boost is 2.5% and 2.2% on short circuit current. And beside these flash tests at standard test conditions with perpendicular light, we have additionally done measurements to investigate angular light behavior according to IEC 61853. And we see an allocated increase of another 0.8% in short circuit current in an angle range of -85 to 85. Overall, the achieved result presented in the TÜV report matches well with the gain expectation and makes us really proud.
Okay. Obviously, we mentioned earlier about new developments and new studies. What have you got from a real world implementation? How can you show people from the work you've done already what they can achieve?
Yeah, I will provide that. Here we have an actual case from Germany. These abstract painting look-alike shows a relative comparison of raw daily power output data on string level. And in this chart, the y-axis is the daily output of strings related to an average of carefully selected reference strings, and that's all in percent. And this is done over a long period of time you see on the x-axis. The vertical green line in October 2019 indicates the date of anti-reflection coding on site. And the black solid horizontal line left from the vertical green line is simply the average of all these colored dots before coding. We call this the baseline. And the black solid line on the right is showing the cumulated relative output after the coding event took place. And we use this visualization to show the power output uplift. We call it the jump right after the coding application. In general, we calculate our business cases with an overall performance gain of our retrofit coding. And the overall gain is defined as difference between the relative output of coded and, of course, reference strings. As I said, it's a solar park in Germany with thin film modules from First Solar FS2. And the value we achieve is significant. 4.2% extra gain creates a lot of benefit. Yeah, and how does a 2.5 megawatt peak solar park business case look like? On the left, you see the basic specification of the site. 2011 park in Italy with medium irradiation and feed-in tariff. A possible 3% performance uplift on these 60 cells poly modules will lead to about 190,000 euro cash in 6 years. You can also calculate it for 5 or 10 years. We have just estimated double of a realistic payback time. And even if you deduct 10 times spring cleaning cost for the following years, our clients still benefit from a double-digit internal rate of return in almost every park we code. So with our solution, asset owners get the opportunity to turn purely cost center O&M activities into a profit center item at almost zero financial risk. Of course, the individual negotiated business case depends on even more site specifics and the workmanship related, but this is something we discuss with our clients bilateral. Okay, now let me close with an outlook. Our DSM Retrofit Anti-Reflective coding is fully commercial in Europe. Coding season 2020 has just started. Of course, it's a bit impacted by these COVID measures, but we are optimistic that we will process our multi-megawatt peak project pipeline, and we are ready for real high volumes. During the year, our team will continuously provide service and bankability improvements. That's never a standstill. We are aiming to commercialize in overseas in 2020 with selected partners who are willing to invest in the equipment and who are willing to set up dedicated teams for execution of the application. Okay, prior to this webinar, we raised a provocative question. Why not spring cleaning your solar park and boost its output too with DSM's Retrofit Anti-Reflective coating? I think the answer is clear. In terms of profit, combining both activities adds extra value from day one. Back to you, Mark.
Great, thanks, Jorn. Looking at the time, let's move on to the Q&A session. I think now I can see there's a couple of common theme questions here for you, Jorn. So let me kick off with one of those. That's, what is the business model, and does the potential customer pay for the system up front?
Yeah, this service is sold as a turnkey solution delivered by DSM's qualified O&M partners, including cleaning off and application on the customer solar panels. And the value we create with this coating depends on a number of factors, like the extra output gain, local conditions like irradiation, the park's feed-in tariff or electricity price, the park layout, the location, in which country, etc. Our pricing reflects the value that we create and provide our customers always with a very attractive payback time and outstanding internal rate of return, I think, compared to other refurbishment solutions on the market. But terms and conditions like payment are part of individual negotiated business cases.
Okay, understood. I guess related to this as well, quite a few questions on, what is the full cost of doing the coating on a megawatt basis?
Yeah, the negotiated business case is always influenced by the park itself and its specification. For example, a to-be coated area of 1 megawatt peak of thin film modules is different to the polycrystalline modules type from this period. So, of course, the size of the park and the economy of scale we can achieve is also something we consider. Our pricing includes the necessary cleaning and coating workmanship. We always provide quick payback times and attractive IRRs, as I said. And in this year's high volume coating season, we also may provide our clients a logistics advantage by clustering different coating events in region. Anyhow, this is something we discuss bilateral with our clients based on these individual solar park or pre-qualified asset portfolio.
Okay, I've obviously got here several related questions from a technical side on the anti-reflective coatings. Let me just put these together. Firstly, how long does the anti-reflective coating last? Secondly, is there a way to remove the coating? And lastly, on this topic, I think, what sort of tests have been undertaken on the actual anti-reflective coating?
Yeah, our coating has been optimized to maximize durability. And the coating comprises an inorganic silica-based network, which is intrinsically UV stable. The retrofit technology is based on the same technology platform named nanoporous silica-based coatings as DSM's leading anti-reflective technology for brand new modules, which has been commercial since 2011. And this technology is now almost 10 years on the market. In all these years, DSM has never had a complaint regarding significant degradation or negative performance of the anti-reflective coating. The coating itself has gone through a stringent, also these independent testing, both in the lab and in the field. Like told, we have executed all the IAC tests most time in double cycles. We also did extended durability tests in radiometers, additional material performance tests, and out those we even carried out post-application cleaning testing studies. And yeah, our coating passes all these tests with minor changes in optical and other relevant properties. And yeah, this gives us really the confidence that the coating has an excellent long-term outdoor durability, at least until the feed-in tariffs in Europe will end. And to the other part of the question, the retrofit coating cannot be removed once applied. Our one-time surface treatment can be compared with a very, very thin environmental friendly paint, leaving a closed and almost even silica surface behind. And this surface is mechanically resistant and cannot be wiped away by standard PV module cleaning methods.
Okay, I get that one. There's a question here from people going on about, can customers specifically select one of your partners for their project or projects, across Europe?
Yeah, understand. We have clear rules of engagement for this. Typically, we serve Italian market with O&M company Stern Energy and Germany with Greentech. But of course, the client has a voice in this. And for example, in Czech Republic or UK, or other European markets, we work with a concept competition, and the best proposal gets the order from us.
Okay, understood. I'm looking at the time here, so let me give you a final question. And in fact, I think this is something a lot of people have been talking about here with their questions. So I'll summarize this as, do the panel manufacturers certify that your coating will not affect their warranties?
Yes, of course. From our existing business, DSM has good contacts and relationships with many module manufacturers, including all tier 1 manufacturers globally. And in principle, the application of the coating is a very gentle process, which puts no or only a very low pressure on the panel, so that these will not be damaged. That's almost zero risk for the panel. The coating itself is not corrosive. It does not cause hotspots, does not change isolation values or whatsoever. And DSM has executed a risk analysis regarding the potential effect of the coating on the module and its components. And yeah, the conclusion is that the risk of degradation of the module due to the coating is simply not there. A formal statement about this is available under NDA. So from several module makers, we have warranty statements, either general or project-wise. And please note that many of the suppliers of the older solar panels, which have no anti-reflective coating, are already bankrupt. And for such panels, warranty is no issue anymore.
Okay, got that. Well, thank you, Jorn, and thank everybody here for joining this PV Tech Talk webinar. Obviously, a copy of this is going to be available online soon. So thanks once again. Thank you all for attending, and goodbye.
Thank you too. Take care. Bye.